Um, Good morning, everybody. This is solution to example 2, and I want to believe that you have gone through example 5.1. If you have any question in this example, you can just go to the module, click on the section where I put question and comment, and put your comments there. I will get back to you once I receive that. So let us look at this example 5.2 together. Horizontal piston cylinder arrangement is placed in a constant temperature bath. The piston slides in the cylinder with negligible friction. The pressure volume relationship within the system can be described by PV equals 2.5, where P is in bar and V is in cubic meter, that is meter cube. Calculate the work done when the initial and final pressures of the system are 1.5 bar and 7.5 bar respectively. We are given relation between bar and Newton per meter square. So the first thing, as I always say, is to bring out your data. So we are given that the relationship PV is equals to 2.5. PV is 2.5. And please take note, with this relation, P is in bar and V is in cubic meter. So we are to calculate work. It means W is unknown, and we are given that the initial pressure, which is P1, is 1.5 bar, and P2 is 7.5 bar. Okay, so we are also given some hints about the assumption that we can make in this. So we have some assumption. We are told that we have a negligible friction. Okay, this means irreversible work, and we are asked that we have constant temperature. Okay, so the temperature is constant. So it is clear now that the formula we're going to use is W is equals to integral of V1 V2 P dV. This is the formula for reversible work. So obviously, it is very clear that if you don't know V1 and V2, you cannot solve this problem, especially when you are looking for work. If you want to calculate work, you must know V1 and V2. But fortunately for us in this question, we are given a relation, that is this one, that we can use to find V1 and V2. Since we know the relationship between P and V, so since I'm looking for V, I will make V the subject of the formula, so I will have 2.5 over P, right? 2.5 over P. So it means if I want to find my V1, I'm going to have 2.5 over P1. and I have my P1, which is, so I will have 2.5 over over P1, which is, what is our P1? 1.5. And this will give us, what, 2.5 over 1.5 is going to give us 1.67 meter cube. This is V1. Then our V2 will be 2.5 over P2, and that will be 2.5 over 7.5, and that will give us 0.33 meter cube. Okay, so now we know V1, we know V2. So, and in this formula, we have to integrate dV. So we are going to use the relationship between P and V to do this integration as well. But please take note, we are going to find our work in SI unit. So our pressure must also be in SI unit. But this pressure here is in bar. So in our formula, we need to convert the bar to Newton per meter squared. So for that reason, our formula will become 10 raised to power 5 to convert our Newton, to convert the bar to meter cube. V1 to V2 P dV. But our P is what? The relationship between P and V. Don't forget, let me show you. This is the relationship between P and V, and this is PV. Now, if we want to substitute for P, we have to make P the subject of the formula. It means we're going to have P is equals to 2.5 over V. So it is this relationship that I am going to substitute in that equation. So if you go back to that equation, we're going to have 2.5 over V dV. I hope that is clear. So 2.5 over V dV. For that reason, 2.5 is constant, so I can bring it out. Times 10 raised to power 5. Integral of V1, V2 is also V1 dV. Right? So what else? This will be 2.5 over V dV. Right? I have taken out 2.5, so it's going to be 1 over V dV, because this 2.5 is out already, is here. So now I hope you have not forgotten your integration. So you have to integrate this. So this will give you lane V from V1 to V2. Okay? So we try to simplify further by having lane V2 minus lane V1. Okay? Then, what is our V2? What is our V1? But in the meantime, we can still make our life simple by having lane V2 over V1. I hope you can still remember the rules of logarithm. Okay, you did this one long time back, so try to remember. So 2.5 times 10 raised to power 5 lane. What is our V2? What did we get for V2? Is 0.33 over, and what did we get for V1? 1.67. Okay, so we continue. If you find the ln of 0.33 over 1.67, you're gonna get 2.5 times 10 raised to the power 5 times minus 1.62. So if you multiply this one, you're gonna get minus 405.37 kilojoule. Okay, so this will be your final answer. I think there is nothing much in this one compared to the first example. So all you need to do is to master law of logarithm, and also don't forget rules of integration. Then every other thing is just normal arithmetic, addition and subtraction and things like that. So I hope you understand this. You can watch this video many times to make sure you get familiar with all the steps that we have followed here. So if you have any question, you can still go back to the section for question and answer, and I will surely answer any doubts that you may have. Thank you for watching, and we'll see you in the next video. Thank you.